Yeah, hi guys, welcome to the present session. And in this video, we are going to see the UGC NET paper 2 electronic science, the last year question, that is December 2020 and June 2021 mid-cycle question paper, so part 1. So in this video, we are going to see the few questions, and in the subsequent parts, we are going to see the few more questions, guys. Okay. So before going into the main content of this video, I am requesting you that all of you please share this video links in your respective groups. Okay, the candidates who are preparing for the electronics competitive examinations. Okay, it will be very much helpful to them. And now while coming off the video, so it is the first question we are going to see, guys. Let's have a look at this question. Which of the following statements are correct? So DSBSA modulation is well suited for point-to-point communication. Okay, and involving the one transmitter and one receiver, and VSB modulation is a linear modulation, SSB is a non-linear modulation, and FM is a linear modulation. Okay, so basically whatever the modulation schemes they given here, DSBSC, VSB, SSB and FM, so all these things comes under the analog modulation schemes, right? Analog modulations. And basically this analog modulations are divided into the two types. One is the amplitude modulation and another one is the angle modulation. And coming to the amplitude modulation, again it is divided into the few types, that is the general amplitude modulation and DSBSC, SSBSC and VSB. These are the different types. And coming to the angle modulations, so we can take that one is the frequency modulation and another one is the phase modulation. So we can divide like this. So now the present question is completely focusing only on the different types of analog modulation schemes. Okay. So now here the point is that while coming to the analog modulations, what we are going to write is that C of t is equal to something AC into cos theta of t. It is a carrier signal before doing any type of modulations. Or else whatever this theta of t is there, we can also write this theta of t as AC cos of omega ct plus phi. Okay, we will write like this. Okay, so now if the omega c is a frequency related parameter, phi is a phase related parameter. Okay, based upon the message signal, if the frequency is changing, then it is called as a frequency modulation. Okay, based upon the amplitude of the message signal, frequency of the carrier signal is changing, means it comes under the frequency modulation. Now based upon the amplitude of the message signal, if the phase is changing, means it comes under the phase modulation. Okay, we can tell as like this. Fine. So but now while coming to the, let's take the general this amplitude modulation general expression. What we are going to write, AC into 1 plus Ka m of t into cos omega ct. We will write like this. So in this case, what we are telling here, it is the amplitude modulated signal. Okay, amplitude modulated generalized signal. So here before modulation, the carrier signal can be expressed as AC cos omega ct. After modulation, it converts into like this. That means before modulation, the amplitude of the carrier signal is AC. After modulation, the amplitude of the carrier signal is AC into 1 plus Ka m of t. That means a variation of the amplitude is there, m of t. That means with respect to message signal. Okay. So here amplitudes are changing. But while coming to the angle modulations, here the parameters are changing within the cosine. Within the cosine. That means, for example, let's take if y of t is directly proportional to x of t and y of t directly proportional to cosine of x of t. I hope you understood the difference between both these two. Y of t is directly proportional to x of t represents the amplitude modulation. Y of t is directly proportional to cosine of x of t represents the angle modulations. That means modulated signal and the message signal, okay, both these two are related with respect to the cosines. So here also, whatever the parameters which are changing with respect to the message signal or within the cosine, so this type of equations cannot be considered as a linear one. So these things can be considered as a non-linear, and these things, just like amplitude modulation types of things, can be considered as a linear type of things. On that basis, we can tell that VSB is a linear modulation scheme, SSB-SC is also a linear modulation scheme, and FM is the non-linear modulation scheme. All of you got the point? So we are differentiating linear and non-linear based upon this concept, these expressions. Okay. So now, as per this concept, and DSB-SC is suited for point-to-point communications, and it involves the transmitter and receiver also. So we can take that A is correct and B is correct, but C and D are the wrong. So A and B, both these two are correct, means we can take option B as a correct answer. Okay. So I hope all of you understood how we are going to differentiate the linear and the non-linear modulations. Okay. So all the angle modulations, means frequency modulations and phase modulations, are comes under the non-linear, and all the amplitude modulated schemes are comes under the linear modulation schemes. Got it? Let's go to the next question. Yeah. So coming to the next question, here they given that in the enhancement type of MOSFET at a zero gate bias. Okay. Usually enhancement type of MOSFETs means there are no the ready-made channels. We need to create the channel in the, for example, if you take the N-type enhancement MOSFETs, we need to create the channel by ourselves, and the substrate is the P-type. So to create the channel, we are using the gate terminal. Okay, so it is the source and it is the drain. So now whenever the gate terminal voltage is greater than the, that means if the VG is greater than the threshold voltage, then only the channel will forms. That means if it is a N-type, means if you are giving the positive gate voltage here, then all the electrons of the P-type substrate will get accumulated at this point. Okay, now the channel will forms. Now there is a scope of flowing of electrons from source to drain with the help of this channel. So whatever the minimum gate voltage required to form the channel, that is called as a threshold voltage. And if your gate voltage is greater than the threshold voltage with VDS is not equal to 0, then the conduction will takes place. Okay. So now if you are giving the 0 gate voltage, means channel will not be formed and it will be in the off state. Now let's come back to the question. So 0 gate biasing voltage, channel conductance is very low. Okay, channel conductance is very high. Conductance is not very high. Why? Because the MOSFET is in the off state. Channel resistance is very low. Channel resistance very low means conductance will be high. Okay, resistance low means conductance will be high. So both these two are the same point. So it won't possible. So it is also wrong statement. It is also wrong statement. Channel resistance is very high, obviously. Why? Because almost the zero conduction will takes place, but they given as a low. Okay, let's take it as a grant. If the conductance is low means, then obviously the resistance will be high. So both these two are the same points. Now we can take A and D as a correct option. So here option B is the correct one. Okay. So if you know the operation of the enhancement type of MOSFETs, then we can easily opt this answer. Okay. Let's go to the next question. Yeah. So coming to this question here, truth tables are given and these things are given. So by looking at this question, we thought that the question is very easy. Okay, but the people has to know about both these two. What is the negative OR and what is the negative AND. Otherwise, exclusive OR and exclusive OR is fine. That if you are taking the exclusive OR means if the two inputs are same, you will get output as a 0. If the two inputs are different, then you will get output as a 1. Okay, so it is the truth table of the exclusive OR gate, and the inversion of this one can be taken as a truth table for the exclusive NOR gate. But while coming to this, what is this negative OR? Usually OR gate means we will take as like this, correct? It is the OR gate. But the negative OR means we will take like this. It is a negative OR. Okay, that means here we are taking the, at the starting point we are taking the inverters here. So let's take A and B and C here, or else Y here. Now Y becomes is equal to A bar plus B bar. Okay, Y is equal to A bar plus B bar. That means so from this expression you can get the truth table. If A is 0 0 0 1 1 0 1 1. Now substitute here. So if A and B both these two are 0 0 means then Y you will get as a 1. and 0 1. So 0 and 1 means you will get as a 1. Here also 1. 1 plus 1 means you will get as a 0. That means you will get the truth table as like this for the negative OR gate. Got it? For the negative OR gate, you will get the truth table as like this. So just check out at which point you will get this truth table. So here it is there, right? So now we can relate that negative OR is, that means A is going to 2. Okay. In the same way, negative AND. How to form the negative AND in the same way? Take the inverter and take the inverter and take the AND gate here, and X, Y, let's take the Z. Now Z is equal to X bar into Y bar we will take. So X bar into Y bar means, so based upon this one, form the, truth table. So X bar Y bar means, X, and let's take the Z, 0, 0, 0, 1, 1, 0, 1, 1. So X bar Y bar means 0, 0 means 1, 1. You will get as a 1 here. And in all the cases, you will get a 0 here. So 1, 0, 0. We got 1, 0, 0 expression here. So negative AND can be taken as this one. So from this one, here we can take the D is going to 1. Okay. So A to 2 and D to 1. So based upon this one, you can opt the answer. A is going to 2 and D is going to 1. Yeah. So here you may take this expression. Fine. So option C is the correct answer. So let's go to the next question. In a multimedia fiber, the number of modes passing at an operating wavelength. So here the lambda is given as 1300 nanometer and the number of modes are given as 1000, and the refractive index of the core N1 is equal to 1.50 and clad N2 is equal to 1.48. They are asking to find out the core diameter. Actually, the normalized frequency or the V number expression can be taken as 2 pi a by lambda into numerical aperture. And this numerical aperture can be taken as root of core refractive index minus clad refractive index. So if I take this one, that is equal to root of, it is 1.50 whole square minus 1.48 whole square. Okay, so simplification purpose, if you are feeling a little bit difficult about this one means, then what you have to do is that let's take it is a square minus b square. What is the expression for the a square minus b square? A plus b into a minus b, right? So a plus b, okay, into a minus b, that is 0.02. Okay, so a square minus b square is nothing but a plus b into a minus b. I took this one, that's 1.50 plus 1.4, it is 2.98. 1.50 minus 1.4, it is 0.02. So approximately take this one as a 3 and take this one as a 2. So 3 into 2 is equal to 6. That is root 6. And here all the decimal numbers, that is here the 10 power minus 2. I left this one 10 power minus 2, 10 power 9, 10 power minus 6. Okay, all these things I am leaving. Okay, why? Because here I need to find out whether it is 100 or 125, 2 point or 6.25. Okay, so I'm not bothering about here the what 10 into 10 power something what I am getting. I'm not bothering about that one. Fine. So I got the numerical aperture as a 6. So now I can take here 2 pi a divided by lambda into 6. So then we can take V is equal to 12 pi a divided by lambda, right? And now the number of modes formula is m is equal to v square by 2. So from this one, v is equal to root of 2 into m. M is given as 1000. So v is equal to root of 2000. Okay. Now substitute the v as root 1000. 12 into pi is 3.14. Lambda is 1300 nanometers. After substitution all these things, try to find out the value of a. Simplify. You will get as 125 micrometers. Got it? So simplify this one, guys. Okay. So these are the questions that I kept in this session, guys, and a few more questions we will see in the next part, that is the part 2. So please make a note of any new concepts you got in this session and subscribe the channel to get the few more questions from the different electronic science competitive examinations. Okay. So thank you very much. Bye, guys.